Part 2 of simplifying with some crazy radical and rational exponent stuff. So, when you simplify, from now on, you have rules. You are never allowed to leave an answer with a fraction exponent. You are never allowed to leave a radical in the denominator. And they must always be simplified as far as they can go. If it just says simplify, it means simplify as completely as you possibly can. So, 3/4 plus 5/4, you know, is x to the 8/4, which we know 8 over 4 is 2, so this is just x squared. Done. There is nothing else you can do. Next example. Notice they have the same exponents. I'm just showing you what happens when you have a number. So 2 to the 3/4 and 2 to the 5/4 is going to be 2 to the 8/4, which you know is 2. 8 over 4 again is 2. However, 2 squared is 4. Take it all the way to 4. You are not allowed to leave this as a fraction, so you must rewrite this as the cubed root of 4. Now, if it could be simplified, you would simplify it. But if we were to break down the 4, we would just get 2 and 2. We don't have enough to simplify it, so we just leave it as the cube root of 4. 16, however, can be written as the cube root of 16. But this can be simplified. You would lose points for that. If you were to break it down using the factor tree, you would get 4 2's. So you would circle 3 of them because that's our index, and we'd box the leftover. So the final answer for this would be 2 cube roots of 2. So it's just a whole bunch of rules being applied all at one time. So you can't let this confuse you. You just need to be able to keep your rules straight in your mind. Next row. A negative exponent, the first thing you want to do is flip it. So this is unhappy in the denominator. So the first thing you want to do is rewrite this as 4 to the 1/2 power. Now you're not allowed to have a exponent that's a fraction. So you must rewrite this as the square root of 4. But we know the square root of 4 is 2. So that all simplifies to 2. Next example. We have 1 over the cube root of 8. Now, you're not allowed to have a radical in the denominator. Luckily for this problem, we know the cube root of 8 is 2. So this just simplifies to 1/2. So before you ever try to say, oh, I need to rationalize the denominator and get rid of that, see if the denominator is an easy fix, like this one. But in this next one, this would be 1 over the square root of 6. And that one, we can't take the square root of 6. So we need 2. We only have 1. So you multiply the top and bottom by the square root of 6 like you used to do. And you end up with the square root of 6 over 6. Done. What is 1 over 6 to the 1/2 power? Or 1/3 power? That would be the cube root of 6. You only have 1, but you need a total of 3. So very similar to the last question, except for you need to multiply the top and bottom by the cubed root of 6 squared. You need 2 more. So then once you have 6 times 6 times 6, and you take the cube root of that, you would end up with your 6. However, that's going to leave you with the cube root of 36 over 6. And you cannot divide 36 and 6. Remember, you can only multiply or divide radicals when they're inside with inside, outside with outside. You can never combine them. And this next set, we have division, which means we have subtraction. So x to the 4/5 minus 2/5 would be x to the 2/5. But you do not leave it like that. You must rewrite it in radical form. All answers must be in radical form. Next one, same kind of problem. 4/5 minus 2/5 is still 2/5, but this is 3 to the 2/5. So that's going to give you the 5th root of 3 squared. So we write our final answer as the 5th root of 9. And this next one, notice that they have different bases. But if you think about it, 4 can be rewritten as 2 squared to the 1/4 power. And 16 is 2 to the 4th power to the 1/3. When you raise an exponent to another exponent, you multiply. So this becomes 2 times 1/4 is 2 to the 1/2 times 4 times 1/3 is 2 to the 4/3. When you multiply, you add exponents. So 1/2 plus 4/3 is 2 to the 11/6. So that means our final answer is the 6th root of 2 to the 11th. Wait, how many times can 6 go into 11? 1 time with a remainder of 5. So you need to pull out a 2. And you have to leave 5 more inside. So your final answer is actually 2, 6th root of 32. Now that was an example of one where you just have to keep on going, following all rules until you get to the very end. Okay? So, let me show you an example of a couple that are a little bit crazy. It doesn't look like the one on the left can be simplified a whole heck of a lot until you remember that when they have the same exponent, they are allowed to have different bases. So 6 times 4 is 24 to the 2/3 power divided by 3 to the 2/3 power. Since they still have the same exponent, 24 over 3 is actually 8 to the 2/3 power. And then, of course, we're not allowed to leave them like that. So we have the cube root of 8 squared. And that's just going to give you the cube root of 64, which is 4. Now, the funny thing is that problem right there could have been done in your calculator. Anytime it's just numbers and no variables, you can just check with the calculator. Last example, and then you're done. When you subtract, or when you divide, you subtract, but there's more downstairs. There's 3/5 downstairs and only 1/5 upstairs. So 3/5 minus 1/5 is 2/5, so that's 7 to the 2/5, but it's in the denominator. Can't leave it like that, so that's 1 over the 5th root of 7 squared. Can't leave a radical in the denominator. We need a total of 5 downstairs, but we only have 2. So we need to multiply the top and bottom by 3 more. And that will give you the 5th root of 7 cubed all over 7. And then you can rewrite that as your final answer, and you're good to go. So I know this was a little bit confusing. It's taking a whole bunch of rules that you've learned and putting them together into a whole mess of problems. Now, I could have separated this into a whole bunch of different videos, but it's not going to be that way in your quiz or test. So seeing it all mixed together is going to be helpful once you start working with this, and then of course these will get more challenging as we get along. So that's it. This is Longo and I'm out. See you bye.